Hi, everyone, and welcome to our Smilefy 3.0 presentation. My name is Ralph Georg, and I am the founder and the creator of Smilefy. As you can see here, finally, we pushed limits again, and I can present you today something that is very special. It's the highest level of development that we have created so far. And it is unique. We do have unique features. We do have unique workflows. And all these workflows and everything what we develop is going to help us to design smiles in a better way, in a faster way, and much more analytical, facial driven, focusing on smile harmony, focusing on all the important aspects of the patient communication. And it is very, very exciting. And thank you very much for taking the time and attending this webinar and being with us for a couple of minutes. You know, we are never happy with what we have, so we're gonna still continuing developing and improving and creating new features, creating easy to use features and workflows, because our goal is to create something really special, to create something really comprehensive and interdisciplinary, and to give, that's the most important aspect of Smilefy, to give the option or the possibility for even unexperienced dentists to see, to analyze, and to have a very comprehensive overview about the patient and what can be done, right? So that's going to change the way we design the smiles, and it's going to change the quality of the treatment plan and the mindset, how we do approach a patient and the aesthetic treatment. Okay, so let me share the screen and start going through the features and innovations that we have. Good. So Smilefy 3.0, what do we have in Smilefy 3.0 as an update? We do have printers connections. We do have CAD features. We do have presets, and I'm going to explain to you more in depth what the presets do. We do have the option to design our smiles in a very, very special way. Gingival fit, tooth deformation, and I'm going to explain what is the idea behind this very important feature that we have for adjusting the smile to the gingival margins. We have calibration and the vertical dimension of occlusion. Also, you can change the vertical dimension of occlusion manually. We do have a very important improvement in the colors and the 3D renderings. And the first step that we need to discuss and to start with our patient is to motivate the patient. Second step is to design and plan the case. And in the third step, we print and perform the treatment, right? So let's start with motivating the case, or motivating the patient. Motivating the patient. So, you know, the Smilefy TNG, the next, or Smile Design, the next generation philosophy. 2D is powerful but superficial. 2D doesn't have any clinical value, and 2D is very limited as a technology to be able to analyze and to create an accurate plan or accurate design in 3D. For that reason, we need something that is very powerful, it's automated, it's based on the eye, and we don't lose the time to create a smile simulation. We just want to motivate the patient in a couple of seconds. We want to find out the two most important questions from the patient. Do you see the advantage of an aesthetic treatment? Is question number one. Question number two, what is your preference regarding shapes and smile? And I'm going to show you now what is the biggest change in our update when we want to discuss and to open the discussion for the aesthetic treatment. So let me go to this patient, and we do have a picture in here. So I'm going to start now for my patient the smile simulation. I take a picture and we go to the process of motivating the patient. So based on the facial analysis and based on the facial proportions, the app proposes the first position of the smile frame. It is facial driven, but in some cases we need to readjust the smile frame, smile curve, because it's not necessarily that the position of the jaw and everything is ideal, right, to the face. And we can here still do some adjustments that we want, like the smile curve, like the position of the smile frame, and so on. In some cases, it's just working without adjusting anything. In some cases, you need to adjust here the smile frame a little bit, and to make it work, we do have the buccal corridor, we do have the ratio, so you have all the tools here to place the smile frame in the correct place. And now the big change comes. You click on the AI smile simulation, and instead of one smile simulation, you get 4 smile simulations done in seconds. What is the difference between all these smile simulations? Number one, you can show the patient the difference between the shapes. Instead of explaining with words, you can show the patient now the difference in shape form. Means we do have round shapes with open embrasures. We have round oval shapes with closer embrasures. We have triangular shapes, and we have a mix of all shapes. So, dear patient, do you see the advantage of an aesthetic treatment? Yes, I see. What kind of shapes do you feel it would represent you as a person, you as a character, right? And then the patient says, that's too round, I'm not sure, but I see myself in here. Triangular shapes, edgy, I like it. Let's continue the discussion by clicking select, and we get the triangular, square, embrasure shapes for our patient. Second question. We do have the dominance of the smile. The dominance of the smile, which is a very, very powerful feature in my opinion, because it makes the facial harmony and the facial energy, it changes completely between a monotonic smile where the laterals are just lying on the same smile curve, right, like the centrals and the canines, or we can reduce or make the smile more dominant by reducing the size of the laterals, making them a little bit shorter. And now we do have a different energy of the smile. I like this version. Perfect. Let's go to the colors, just readjust a little bit the brightness of the posteriors. And our patient is motivated. Our patient wants to know more about the aesthetic treatment. Here we go. We have the slider and we have the side-by-side picture, right? This discussion took me 3 minutes. And that's the most important thing. Technology needs to help us create something like this in seconds. And I was focusing much more on the discussion with the patient to find out preferences, expectations, and so on. Because if we design half an hour a smile and the patient doesn't see himself in this new smile because the shapes are too round, closed embrasures, open embrasures, whatever it is, then we lose this time for nothing instead of finding out what the patient's expectations are. So the smile, the motivation of the patient, seeing the advantage of an aesthetic treatment and giving us some important information like the dominance of the smile, the form of the shapes is one of the most interesting and important aspects of the discussion to motivate the patient to go to the next step. So that's the big change in the smile simulation. We do have 4 results, right? We do have 4 results, and I think that's going to be very, very powerful visual communication. Instead of explaining or going into the design and changing shapes and trying to find out what the patient likes, I just click on the picture, I get the smile frame, I click on the smile simulation, it takes me seconds, and I can explain visually to my patient what is the difference between the smiles, right? And you see the energy of the face. Here is more round. Here is the friendly older gentleman. That's more edgy. The square embrasures. Maybe this one, it's too feminine, too much gums. This one is also nice. It is friendly, but is round. It's not very edgy, right? So now the patient has a lot of versions to compare and say, I go with this version. I like this version very much. Select, and here we go. Here is the point where our discussion starts. Why do I tell you, or why do I say, why do we teach that the 2D smile simulation is useless from a clinical perspective? Because number one, 2D smile design 10 years ago was a very genius idea, and it was the only way to motivate the patient and to create something that shows the patient the advantage of an aesthetic treatment. If we try to find something clinical in the 2D design, we do have a lot of limitations, because number one, the position of the face of the patient is not always perfectly frontal to the camera. If we don't have the frontal position to the camera, then the angulation of the 2D shapes that we use as a 2D design is created on a picture on the templates that are always frontal to the camera. So if this is my shape frontal to the screen, and the head of the patient is like this or rotated to the side, this is not a representation of the 3D template rotate. So when you create a 3D design or a mock-up, this mock-up is going to look completely different than your 2D smile design. And that needs to be very clear, that 2D design has a lot of limitations through the fixed outline that represents this template, and the 3D design is a dynamic design which changes the outline of a smile through the rotation. So that being said, we have our patient motivated, and now we go to the next step. And the next step is, of course, creating the mock-up for our patient and the 3D design for our patient. So the point is that when we design a smile, right, we have the 3D templates like this, and these templates are STL files. These STL files are files to be printed. We send them to a printer, we send them to a milling machine. So these files are STLs or OBJs, and these files are actually specifically created for print, CAD operation, and milling. The 3D design looks not very natural, right, with these kind of designs. And you know that ExoCAD and all other companies, they use the same files, OBJ or STLs, and then when you do the 3D design, it looks like this. So what I did, I was developing and doing research for a way to display the 3D design in a very, very natural way, in a very special way, to be able to have visualization of the 3D smile before we go to print. So I developed, in my humble opinion, the best rendering, 3D rendering system in dentistry to display the 3D design in a very, very natural way. So let me show you how that looks like. If I'm wrong, please show me something better. I'm very humble in this area, but look at this rendering. So that's a rendering for ceramics. You see the denting, you see the enamel, everything is perfect. And we can add now more and more textures. We can add more materials like zirconia, like composite, like everything what we want, ceramics, right? Ceramics, and we can display this kind. That's a 3D design, right? That's a 3D design with all these textures and the smile. You can adjust the colors to the picture and have, before you print, a very realistic visualization of your 3D design in the mouth of the patient. We do have also the Vita colors integrated here, so you can select M1, M2, B1, C2, whatever it is, add on top of the ceramics, composite material, or whatever it is, and then visualize the smile in this way, right? I think that's really powerful, and we can create something that looks more natural. Let me see. Where is it? We can visualize our aesthetic treatment in a much more natural and in a better way, with light reflection, with position of the light. I'm going to show you everything inside the app, and that's really super cool. Now, 2D smile design, 3D smile design is fine, but one of the biggest challenges that I had over the time, not only now for the last couple of weeks, was we do use in our app, we do use the natural templates, right? Scanned from patients with beautiful teeth. We create these smile donators. The smile donators as a concept was started by Paolo Cano and Christian Coachman and Jan Haito, of course, the pioneer of the smile donators. So Jan Haito created 2006 a book with models, with stone models of patients with beautiful teeth, natural forms, right? And he uses these for the technician used these files, these stone models, as an inspiration to wax up the designs. Now all the teeth were in a digital form. We imported everything in Smilefy, so now every single template that we have is not a computer-generated shape, but is a smile donator, right? The smile donators, the morphology of the tooth is very natural and beautiful. So when we design and try to adjust the gingival margins, we use brushes. Every single software uses the same brushes and tools to make the gingival margins fit, which of course destroys the morphology of the natural tooth. There was a challenge because I wanted to keep the best quality of the surface, of the buccal surface of the tooth. I wanted to keep the quality and the resolution, but to be able to adjust the gingival margins in a different way. And what I'm going to show you is very easy to use, and I think it is something that is so much fun that I was really working to improve every single step of this workflow. And the results are really special, not only because we can now adjust the gingival margins, but because we also can redesign the nature of the tooth in a way that we open embrasures, closed embrasures, change, for example, the form of the tooth to a triangular one from a round one, not destroying the morphology, keeping the same quality. So when you mill on where you print, you're going to have all the natural structure on the tooth, but the deformation is going to be adjusted and customized for your patient. So let me show you how that works, because to see it visually, it's going to be much better. So you see the incisal edges are placed perfectly. We do have everything done, but we don't have the gingival margins. Now, with these dots, I deform the surface, the buccal surface of the tooth in a way that I don't destroy it. I just reform. I just reform the surface and make it very, very precise to the patient's gingiva, keeping the quality of the natural tooth. So you see, we have the points. In the meantime, I already added opacity so that we can reduce opacity of the model, and then we see the points that are behind because we have 3 rows of points, and then we deform the surface very, very easily. That's a real-time screen recording, right? So as you can see, it takes 15 seconds. And look at the quality of the design and look at the quality of the gingival margins. Now, with this one, I'm gonna create this tooth a little bit more triangular, right? Triangular, adjusting the gingival margins. And look how the result looks like. So we can create from a good smile design, we can have an excellent result using this technology. Now, if the template is very bulky, right, I can flatten out the surface and change actually the curvature of the tooth by flattening it and keeping the morphology almost perfect, right? Almost perfect. It's the same morphology, the same quality, and we just remodeling the tooth with this technology. So your mock-up that you design is going to be much faster, much more beautiful, and much more precise, because now we can easily finalize the mock-up with using this tool. So if you do have questions, please ask in the chat. I'm gonna answer every single question that you have. Yeah, we can discuss every single detail, because you see, we do have a lot of new stuff, and I'm very excited for every single feature. But if you have some interest, then we can do it and answer your questions. So for advanced, very advanced users with really a big vision for aesthetics, you do have a tooth, you do have this natural template, and you envision the same structure, the same template, a little bit different. Closed embrasures, more flat incisal edges, open embrasures. So instead of trying to find another template that fits or fulfill your vision, what about you change this template using the same technology, keeping the same morphology and structure in the best quality, and just, you see, I move this corner, this mesial incisal edge up, and I reform the lateral in a way that I need eventually for my design. So you can really go now into detail and say, I do have my templates, but I want to create something so personalized and so customized for my patient that nobody has. You have the tools, and the big goal was, no matter what we do with our templates, we keep the natural quality of the morphology forever. Of course, everything what we do, we need to, these are all small changes, right? So I cannot deform the morphology 50%, right, and keep the same structure and the same quality. But for this purpose, this technology is perfect. Okay, let me answer this question. So can the software allow us to go from design straight to print a 3D mockup without having to print a model of the design and then The impression. Not yet, but that's a very good point. We could create for you actually the silicone key, right? That's what you ask. You want the silicone key that you just print, put bisacryl, and just design and just put in the mouth of the patient without doing the silicone key manually. Yes, that's something that we can do and we will do. Yes. Good. So let me show you now. Let's go back to.
Hi,
Hey.
Ralph.
Hi.
Hi. So the doctor here is. Hi, everybody. The doctor here is asking if we can actually print the shells. He said it like the problem that he's having right now is the fact that we have to print the entire model.
Oh.
So he's asking if we are able to 3D print the shells instead.
Let me show you. That's a good question. Thank you very much. So let's go to the 3D design. So whatever you produce in the app with CAD features, with whatever it is, now you can export to the printer. Oh, that's the wrong presentation. Let me check. Here we go. You can create shells, you can create mockup, you can create whatever you want, and you can send your model directly to all these printers. Acoreta, Asiga, Formlabs, Nextend, Sprintray, Desktop Health is new, and another one that I always forget the name. I need to make a note on my palm. Yeah, so we have like 7 printers, and you can send the model or whatever you produce in the app directly to the printer. That's the first step. Now let's go to the design. So we do have the design here, and I'm gonna open a 3D design here. One big change in our 3D design is are the CAD features, right? The CAD features, but CAD is sometimes it's very complex. CAD is you do have a lot of operations, you do have a lot of stuff. I wanted to make the CAD features easy for you because that was one of the main goals of Smilefy. Everything what we do needs to be simplified and needs to be easy to use. So for that reason, yes, okay, unzipping file. I just need a cup of water. So we do have the design, and I'm going to explain to you now the changes in the software and what we have here. So number one change is we do have the same tools, of course, but we have a little bit, the menu is a little bit different. So we have design and advanced. So let me go to the design. We do have 4 views. Of course, you can change every single view and you can go and see only one model. But for us was always the point of seeing your design from 4 angulations so that you can design easier and faster, right? Here we go. So we have occlusal view, we have the 12 o'clock, and the frontal view is here. What we have integrated to make it easier and simpler, we have integrated key shortcuts if you use the Mac and the keyboard, right? So of course you can use position, you can select your tooth and select position, rotation, and size. But what about you use the keyboard and you say F is smile frame, right? L is lip. So we put the design into the lip. I select the tooth, and now H, I increase the size. Shift H, I decrease the size. W, I increase the width. Shift W, I decrease the width. Arrow up, it goes apical. Arrow down, it goes coronal. Arrow right, it goes now mesial, and arrow left goes distal, right? So with the keyboards, we can do the design much more faster and more efficient. You can use the buttons, you can use the control, of course, here, you know, if you have if you use the transformation tools here, so you can move the tooth with the mouse, you can use the buttons, you can use the keyboard. You can simulate, of course, the smile here, the mark lip, and so on. That's the tools section, right? So if I go, for example, and I increase the width and I like the central, I just go and select the other central. The left is going to be reflected to the right side, and now both centrals are the same. Now I messed up my design, and that was one of the main feedbacks for you. Ralph, we need an undo button. Here we go. We have the undo button. Undo, undo. Okay, here we have the undo button, and we have the redo button in case you say, the first version was better. So redo, undo. I think we have 5 steps. I integrated 5 steps to keep the memory usage low, right? But now, whatever you do, in case you say, okay, I'm gonna try to change the rotation, I don't like it very much, undo, you get the initial position back. Okay, thank you very much. That was your feedback. Here is your feature, undo and redo. Tools. Then we have options. Options are pretty the same. You can group all the teeth and then move them grouped. You can see the 3D outlines to just analyze the interproximal spaces, to make sure that the alignment is properly done, to have the outlines, to see it is a crown lengthening case. Do you want to do a crown lengthening case? If you have the CBCT also aligned in the background with the outlines, you see the bone margin, you see how much do you need to reduce, and all these clinical details that you can use, for a better design and better planning. We do have the templates, and we do have the aesthetic templates. We do have the prep models. So we have the dices in case you need to rebuild the broken prep, the old prep of your patient. You can use these dices here, and you can create with composite a model that you can then rebuild the prep. We do have Gingiva models, right? So if you create the full art implant bridge, you can use the Gingiva up, lower and upper. Or if you have an extraction and bone loss, for example, you can use the prosthesis Gingiva for this tooth, upper and lower, just to fill out the space using one piece of the prosthesis Gingiva. 3D layers. Here it becomes interesting. So what do we have in the 3D layers? Number one, we have the 3D light, right? So we can put light on the model, right? To see light reflections, to see the teeth, and in a different way. Also here in the mouth. We do have the position of the light. You see, you can move the light up and down. We have the brightness, of course, of the light. And the side lights, because sometimes the teeth in the mouth the posteriors are darkened, so you can darken actually the posteriors here. We do have the Vita colors. So if your patient has D4, you can make it more yellow. And you can stamp with the user option, you can stamp the color of the user and then transfer the color of the user to your upper teeth, right? That's more of a working color, okay? A working color to see the design in a different light, in a different way. Because, as I mentioned before, we do have the 3D colors. So I'm gonna check the 3D color, and now you see we have a different rendering on the teeth. We have the denting, we have the transparency, we have the light reflection, we have here the shadow of from the light reflection in between the centrals, right? Of course, I can change the brightness. As you can see, I can change the brightness here. And now I can apply a Vita color on top of my rendering. You see, with the color intensity, and I can create something that is very similar to the patient color, right? So if I present now my mock-up, for example, like this, and I compare a real picture with colors from ceramics, it's gonna be very, very similar. It is a different way to present the smile as like this, right? that's a little bit too technical. It's a little bit too, yeah, it's everything is done for printing or for designing, and patients don't understand, right, why the teeth are so white. Good. That's the 3D colors. Then we have here all the layers that we have inside the app and the project metrics. Now, I want to explain the project metrics because that's a unique feature, exactly the same way like the 3D colors. It's a unique features. And I want you to imagine you start with the first design. The design is original templates. Then you do the mesh deformation and you do the gingival adjustments for your design. Then you have an original design and a mesh edited design. In our project metrics, you will gonna be, and that's unique. If another system works like this, beautiful, but I don't think so. You can jump from the original design to the mesh edited design. If you do CAD operations, you can have the metrics on CAD operations, so you can switch between all the versions of your design. You have original, you have mesh edited, you have CAD features, and you do have all these layers, right, immediately accessible if you want to jump back. Why is that important? So let me show you, for example, and that's really, really powerful in my opinion, because let's go, for example, on the CAD features, and I'm gonna delete this one so that we don't have any CAD features here. That's my original design, right? That's my original design. I want to do the CAD operations. I'm gonna create shells mockup using this preset. I want to create a mockup using this preset. So I'm gonna click on the mockup, and now the app is calculating in the background, creating one file, the mockup, right? So I don't have the intraoral scan and all 6 teeth. I have only one file, the mockup. Version 1. So now it's calculating. We need to give the app some time. Operation. Now you see the percentage of the calculation. So let's see. Until it's calculating, let me explain what is the idea behind this. Oh, it's already done. Okay. So here we go. Upper design in maxilla. That's the mockup. Mockup 1. Let's put on this color, right? I have the first version of my mockup, but now I'm thinking, oh, maybe the centrals. I want to create a second version. Maybe the centrals. I'm not sure about the centrals. Okay. I select the different centrals. Select here. Yes, I want to continue. Yes, I want to continue. So you see now I have different centrals, right? Different form. Okay, now I go back to my advanced, I click mockup and I create another one. Now I have mockup version 1, mockup version 2. So I can present my patient 2 versions of the design in seconds. The same way we can create the shells. I'm going to show you now the shells. So that gives us the the flexibility, right? The flexibility to not be trapped with one design in which the patient says, maybe I don't like it, but to have different versions of the design done in seconds. So now I'm gonna hide the design and all the stuff. I have mockup number 1, mockup number 3. Different centrals, one file, all the design united. You see, that's the first mockup. Now I have 2 versions of the mockup. If I want to see this mockup in the mouth of the patient, right, like this, mockup number 1, mockup number 2. Done in seconds, right? I think that's a big advantage, managing all the files and all the designs in one project. Because tomorrow the patient is gonna say, beautiful, I want different canines, I want flat canines. I don't need to redesign from the beginning. I just go to my templates, I change the canines, I transfer the size, the rotation, and everything what I have from my design to the new canine. You see, like this. And now I have a new canine. I can create another mock-up. I have 3 mock-ups in 1 minute. The only thing is we need stronger computers, because I want to, I don't want to wait, right? I want to have it immediately, now, mock-up now, click. So Apple has to develop a better, on the other side, my computer is like 3 or 4 years old. So, I mean, if this computer is working like this, the new ones, they should be good. So here we go. We do have a complete new design, having now different templates. The only thing that you need to consider when you change the shapes, the size and everything is the same. The only thing is, if you have, for example, if you have template that is more flat, right? It's more flat, then we need to readjust the position of the flat template, because eventually it doesn't cover the patient's teeth, right? Now I can do my adjustments if I want to, like here, adjustments, that's good. I'm gonna move it like this down. Okay, adjustments, it's fine. I like it. I can go with the mesh editor and yeah, adjust here the gingival margin on that one. But I'm gonna do the mock-up again, and now I have 3 mock-ups done like this in minutes, right? Good. That's the CAD feature. So what are the presets? CAD operations are very complex. For CAD operations, you need a lot of different operations in the background. For example, to create temporaries, right? You have the model, you have the prep, you have the design over the prep, and now you want the temporaries in one piece milled or printed. Mockup number 4. Where is it? Here. Mockup number 4. Mockup number 3. Mockup number 1. That's the way we should discuss and plan cases, right? Now, what I was saying, the option, the 4th option, the 5th option in this design. Oh, no, the presets first. Excuse me, the presets. So let's go with temporaries. What does it mean I want to create the temporaries? I have 6 teeth. 2 of them are veneers. 4 of them are crowns. So I need to go select the canine difference. The app creates the difference between the intraoral scan and the canine, and I get the veneer. Difference between the intraoral scan and the lateral, I get the crown, and so on. At the end, I have 6 different teeth, which I need to union together, stick together, and then I have my temporaries and I can mill them. What about you have one button, temporaries, you click on it and everything is done in the background, all the differences, all the unions, all the intersections, all the whatever. It's a preset, right? It's a batch operation and you get the temporaries. You don't need to worry about every single tooth. Just the design needs to be accurate, just the design needs to be precise, and you get the temporaries in one click. Veneers, you want the veneers. Now I clicked on the veneers. You get every single tooth as one file, right? As a distinct file. That's the veneers option. Shell mockup, differences, canine to canine, union, canine to canine, and then you get the shell mockup that you can export and print. The mockup is the union of all teeth with the model. You get the mockup. Full art implant bridge is going to be super interesting because full art implant bridge is much more complex. It is, you have 16 or 15 or 14 teeth or whatever it is, 12, 14. Then you need to design, put the prosthesis gums on top, unify the prosthesis gums with all the 12 teeth, then subtract the teeth from the gingiva of the patient, and then create the holes for the implants. A lot of operations if you need to go one by one. What about you click on one button and we do all these operations in the background and you get the final full art implant bridge like this. These are the presets, and we're gonna integrate more presets for night guards, for crown lengthening, for much more presets. And you are not gonna worry about what you need to do. You just say, I need the crown lengthening, boom. I need the mock-up, done. I need the shell mock-up, done. So that makes everything much easier. Good, so these are the presets and the CAD operations. We do have more operations. We just need to finalize now these veneers operation, and then I'm gonna show you the digital edit option. So do you have more questions? So now we have here the operation. Let me see, where is here we go. Oops. You see, I didn't clean actually the palatal area properly, so that we can have clean veneers, but it's just you understand the principle, right? So now I can select one tooth. These are the Boolean, right? These are the Boolean. Here is my project. And now I have the original design. I have the Boolean. I can click on the tooth, right? And then the matrix asks me, what do you want to have in the project? Do you want to have the Boolean version of the tooth? Do you want to have the original tooth? Do you want to have the mesh edited tooth? So you can jump between your versions easily for every single tooth. Okay, there's the 3D layers. Now let me go to a very, very cool and important feature that I really like very much. I put a lot of research and effort in this feature, and it's fun. Smile analysis. We can design and create a good smile. What if we don't want a good smile? What if we want an excellent smile? What if we want the most harmonic smile that we can get for our patient? So for that reason, we need a research and scientific papers for 30 years in a workflow that helps us seeing what is the issue with this smile, what is the harmony issue with this smile. So first of all, we have the smile proportions, right? So I have the red proportion. I see, based on the facial analysis, AI facial analysis, I see the red proportion is here and it matches my lines with the face. So that's good. Facial analysis shows me the facial flow of the patient. I have the chin philtrum, commissural intrapupillar line, and the facial flow of the face. And that's my design now in the face, right? That's my design in the face. Good. Smile analysis. Number one, Zenith analysis. Zenith is the highest point on the gingiva, central, lateral, canine. I place the points at the highest, at the zenith, right? Here, here, and here. And you see the model jumps and rotates automatically after I put the point. And it's here. So now we have two triangles. That shows me the distance between the canine, zenith, and the central is 15.8 millimeters. Here is 15.3. The distance between the zenith of the canine and the lateral is 8.4, 8.7 on the other side, 6.8, 7.6. The angulations between these points are 5.8, 7.4, 166. What does it mean? It means that I do have an issue on one side, right? On one side. So my smile is not in harmony. It's not symmetric because I have different values. The difference in this case is made by this gingiva, right? Because this gingiva, highest point of the lateral, is different than here. So I do have an issue here. It's a recession, I think, and I need to recorrect the gingival margins for the lateral so that I can have a symmetry between this one and this one. Let's see what the ideal design says. The ideal design connects the highest point. That's a tutorial and a course that we're gonna organize in Smile Harmony, and it's gonna be really with all the researchers and the scientific papers and the biggest specialists that we have, you know, to discuss all these aspects of the smile. But let's take this case. What do we have here? We have the line, the green line that connects the highest point of the template, and for canine and lateral, the midline of the incisal edge, and the midline of the central and the midline of the incisal edge, right? So we have these points connecting the templates. These lines are fixed. These lines are created based on the template that we use. And now we see here that this canine, the angulation of this canine is 2.2, and this one is 2.8. So we do have a discrepancy in the angulation. So I'm gonna select this one, and I'm gonna create the same angulation. And now you can see visually that we have, it's very important to have this model perfectly frontal so that we can see the angulations. Let me see the, where is the line? Referent lines, like this. Okay, good. So now we have the same angulations. 4.4, and that's 5. So 4.4. 1.4 and 1.2. Here we go. Now we have the angulations of our design, the same angulations on both sides, right? That makes a lot of difference when it comes to the small details of the smile design. right? Because this facial harmony that we want to achieve, we need to go in every single aspect of the smile, analyze and change. So instead of just having uh, visual the visual analysis of the smile, which sometimes, or if your designer is not very experienced or so, right, it can be you don't see all these details. Let's analyze I'm an engineer, let's analyze the angulations. 4.4, 4.4, I have the same angulations, it looks better, it creates a better harmony. Let's go to the ratio, right? Let's go to the ratio. Let's see, what do I have here? I have my central, let me like this, I have my central. So I'm gonna put the lines on my central. Here is the gingival margin, the visible gingival margins of my tooth. Here also the gingival margin of my tooth, incisal edge, distal and mesial. Where is it? Here we go. Yep. I'm going like this. Okay. The ratio of my centrals are 78, 87, 87. Gingival highest point gingival margin to the incisal edge. Just imagine I do have now this central is like this, right? I don't necessarily see it that is longer. I set my points, it's 83% ratio, means height 100%, width 83%. So I know, oh, that's the analysis of my smile. I'm gonna reduce the position here. That's the same line. Now I'm gonna reduce the height like this, readjust here my position, 87. Now I do have the same ratio for my centrals, because the centrals, they need to be the same. They need to be the same size, same rotation, same angulation. We see first the centrals in the smile. The centrals needs to be really symmetric, and the way it creates this whole the facial harmony and everything else. So that's the point of the centrals, right? That's the ratio. Smile analysis, we do have the analysis of the zenith, angulations calculated automatically. You just need to set the points. We have the angulations of between the highest point of the gingiva and the incisal edges, and we have the ideal, where we can see the discrepancy now. In this case, on the left side, that's pretty the same, right? It's pretty accurate. But here we see that the highest point is shifted. That's the ideal. So you have now an idea for the treatment. I hope this smile analysis, you like this feature, because it's very analytical and you get much more insights into the smile design and ideas for the treatment. Because I don't think there is we can create a smile design so white and pink. But smile design is not only teeth. Smile design is also gingiva. Do we need a gingivectomy? Do we need a correction, right, of the gingiva plus the teeth? And then we get the most beautiful harmonic smile. So now we can analyze both. Yes. You can print directly the veneer design and whatever you want. So let me create for you now, for example, let's create shells, right? We can create shells, you can print, you can design, you can print, and try the model directly in same appointment, even same appointment. If you use, for example, a printer that is very quick, like we use Nextend, it's behind me, you can get the shells in 15 minutes. Your patient can drink a coffee, have water, just you print, you cure, you can try the shells in the mouth of the patient, same appointment. Dentsply Sirona Prime Printer. I think I was in a call with them. I need to check where we are, because the idea was also to integrate the Dentsply printer. Yes, the Dentsply printer. Good. Let me see, where are my shells. Here is Smilefy. Okay, so I created the shells mockup, shell mockup. Here we go. Here is the shell mockup. You see, that's the shell mockup that we have created. Yeah, I didn't mesh and cleaned, you know, the edges so that you can get the clean model. But that's the point. You create the shell mockup. Now you can save and send this mockup to the printer. Right? Smile analysis and mesh editor. So the mesh editor is more or less the same like our normal version, with some new features like the deformation and swirl. So and the gingival fit. That's gonna take a little bit more time to calculate, but I can show you what actually this deformation shows or do. This deformation, you can deform a corner of a tooth, move a corner mesially distally, right, and change the triangulation of your tooth with these features. Swirl, it's a very interesting feature because sometimes you have the incisal edge. You have the incisal edge like this, right? And the gingival margins is a little bit rotated. With swirl, what you can do is, that's the incisal edge. In the back, you have the top part of your tooth, and then you can rotate this top part, like, you know, like orientate the top part on the gingival margins. That's the swirl. And then we have the gingival fit. Gingival fit is you set points on the gingival margins of the patient. You set the points here, defining the gingival margins, and the tooth is calculated automatically and adjusted to the gingival margins. Or, of course, we do have our mesh editor tools, which are now different because they are in the 3D Smile Design screen. So if you do the mesh, you can have the changes in the mouth of the patient, which is, of course, different, and it has much more advantages, right, to see the changes now in the face. Let me show you. Now I am gonna take the maxilla and the upper design. Like this. So do we have more questions? We're about the palatal stabilizer for shell mockups. Yes. Yeah, because the way you design, it doesn't matter, right? It doesn't matter how you design, but now we calculate the difference between the design and the patient's teeth form. So the teeth are gonna match exactly the patient's form, and you can create now, for example, if I want to create shells, right? I'm gonna take the flatten. I'm gonna flat here this tooth here. I'm gonna flat, right, like this. This one is, I can keep this one as a stabilizer. I can I'm gonna delete this one. So for our shells, you are gonna have these 6 teeth as one file, but the laterals are gonna have the stabilizer for the incisal edges. So you're gonna click the whole design, the shells on the laterals, and canine and centrals are gonna be on top of the teeth. So it depends the way you want to design your shells, but that's now exactly the way I showed you. So like here, right? So you have the form. So you can deform and go here to the gingival margins. I don't know and here, right? You saw now we have the deform. I deformed it in the gingival the margins here, and that's the way. I don't know the color should be not the same color like the model, but I need to check what happened to the version from today. But that's the way we do with the mesh editor. Okay, so you can produce, you can print directly. Okay, so let me show you. Yeah, we do have 3 more features that also, but I need a case with the lower jaw. I think that's with the lower jaw. So now we can open the bite digitally without the bite registration, which of course we recommend to use a bite registration to set the position properly with the patient, right? But if you don't have the option to use a bite registration, you can open now the bite digitally. So Gabriel, did I answer your question? You can add a palatal stabilizer for the shell mockup. The answer is yes. You design, and the way you design, and you let the incisal edges stabilize over the incisal edge of the tooth, then you get the mockup perfectly matching the patient's teeth, right? And then you can get this stabilizer. The shell mockup is very, very powerful when you design a crown lengthening case and you need to go over the gingiva, right? Then you can simulate how far you can go with the gingiva. So video. So what do we have in the video? Let's suppose we don't have the bite registration and we need to open the bite. Video open bite digitally, and now you have the distance, 3 millimeters, and you can close the bite also, right? So you can close the bite, you can open the bite. Let me turn off the colors because then and the light, because then it's better to everything works better without the rendering. So you can open the bite. Now that's the new position, and you are gonna design the your smile with the open bite. Reset brings the bite into the initial position. We do have integrated a study from a Japanese dentist and researcher called, I forget the name always, but that's not good. The study shows actually that the vertical index, CEJ to CEJ in centric occlusion, can be 19 millimeters in the ideal, oh, I need to activate the ruler. Okay, so I put the point here, and it's 17.71. Now, when I want to open the bite, I can open the bite. The ruler stays linked, and I can open the bite to 19 millimeters, right? So that's the vertical index, CEJ to CEJ. Digital edit. So the digital edit gives you some options to, number one, to extract the teeth. If a tooth is in the way, right? I can extract this tooth. I can cut the object, because you see, in this case, we do have at the top, we do have a lot of stuff. So what I can do is set the plane like this. I can move the plane up and down with the arrows here. You see, up and down like this. I think that's good enough. And now I can cut. I can cut the intraoral scan. I can clean the top, and then I can put a base on the top. Simbashi, thank you very, very much. I always forget this name, and I cannot forget this name because that's a huge reference. And Dr. Simbashi is a huge researcher in the vertical index, right? And that's this study is integrated now in our app so that we can go with the optimal vertical index CJ to CJ. I cut the upper jaw, and here we go. I can put a base, right? Here is the base. Now I can bring the base like this. That's good. And here we go. You can print with the base. Of course, you can reduce the size of the base by selecting the base, clicking S, size, position, so that you reduce actually the material that you print. Right, you can reduce the material that you print. You can also, if you select the size, you can reduce the height, right, the thickness of the base. And here we go. Then you have the base and you can print, right? So I see that many tools create the base like huge, right? Like huge. When you print, you use a lot of resin and it doesn't make any sense. So that's why I integrated here for you the option to save resin and to create the base as you need. There's the digital edit. We do have the canine guidance. That's just a way for you to check the smile, but it's gonna be much more advanced when we bring movement into the app. Occlusion, function, movement. We're gonna import the movement from Mojo, from different systems, and then you're gonna be able to add movement to your design and then see where are the issues. Video, CAD features, and design, and the colors. Yeah, I think that's it. I think that's the Smilefy 3.0 update. Yes, I want to. So how can I export now everything what I produce, right, in the app? I go to my design, to my case, and digital patient. In the digital patient is everything what I did. Thank you very much, Jack. Thanks. So I open the digital patient version 2, because now you can select which version do you want to open. Otherwise, you have 10 versions and you don't want to open 10 versions and wait until you download from the cloud all the stuff. You say, no. Version 2 was the version that I want. We download the files. You have now the design, the shell mockup. You see, I created the shell mockup for this case. I have here, that's the shell mockup. I can go to 3D. And now I have the option to export the files. You see, shell mockup. That's my shell mockup. Again, this shell mockup is not clean because I didn't mesh properly with the brushes. I didn't delete everything in the palatal area. That's why we do have all this stuff here. But nevertheless, you can export and print. Now you have two options here. I need to increase the speed of this zoom because I'm gonna get old until the zoom is increasing here. So these are the shells, right? I do have export and print, so I can export all the files from that case, and I get everything in a folder. I get the pictures, I get the design, the teeth, the CBCT, everything is superimposed and calibrated when you want to use a different software, but the mockups, the shell mockup, everything is in a structure. Oh, let me export and show you. Plus, then you can send to the 3D print. Can the design gingival reduction guides with the software? Yes, that's gonna be, we are not done yet. I suppose we're gonna need around 4 weeks, and you are gonna be able to export and to produce the crown lengthening guides. The crown lengthening guides, and then you're gonna be able to to export, to print, and to use them. The only thing that is I think it's here. Yeah. Okay. So let me show you. The only thing that is missing right now from that feature, you see digital records. We have the shell mockup. Here are the shells. Digital records, the picture. Export CAD means that we have a file that you can use to import into ExoCAD or different softwares. And project files, which are the intraoral scan, the mesh edited teeth, and the project teeth, like the design in one, and then every single tooth as one entity, right? So you have here, if you have mockups, then you get here in the digital models, you get the mockup, you get the shells, you get all the projects, all the files that you create, right, with the app. So let me explain to you what is missing in the crown lengthening. You know that our software runs on Mac, runs on iPad and on iPhone. CAD features are very require powerful devices, but I don't want you to be trapped with an iPad that doesn't work and you cannot create the guides. That's why we combine the calculations between the app, the local app, and the cloud, so that if you have an iPhone 11 and you want to create, you see the design is fine, and you want to create the guide, you can create the guide from the iPhone 11. You can create the guide from your older iPad, and it doesn't bother so much that you don't have enough memory, for example, to create all this stuff, right? So we want you to not to be dependent on a device form. That's why we try to create everything in a very, very safe way. What printer do we recommend? It depends on what exactly do you want to do, right? If you need production, if you need speed, if you need volume, then you need to decide for a printer that prints very, very fast. Nextend, you can print things like this in 20 minutes. Shells you can print in 50 minutes. Mock-ups and all the stuff, we use it in our courses because we can print 16 models in 2 hours, and then we can work, properly. If you want, for example, to use Emacs and to press veneers based on our design and our natural templates, then you use Asiga. Very, very precise print, very accurate. The quality is the highest possible, and then you can print with the special resin the veneers, and then you can press them. So you need to decide for what purpose do you need a printer, right? Some of them, they have resins for aligners. Some of them print very fast. Some of them print very precise. It is depending on what's the purpose of the printer. You see, I was tested positive for a new variant, Smilefy 3.0. So I do have now my shells, and I want to print my shells with Accurata, Nextdent, Sprint Rate, Desktop Health. Oh, Desktop Health, we already integrated it. Formlabs, Asiga, and Flash Forge, that was the 7th one, Flash Forge. So all these printers are integrated. You can use whatever you want, right? And you can then print. So I'm gonna send to Asiga. So let me show you what happens. Where is it? And project files, right? I'm gonna go with digital models. I'm gonna select the shell mockup and send to the print. Now, oops, let me share the entire screen. Now the printer is selected here, shell mockup, and you see I get the model here to be printed, my shell mockup. So that's the way it's connected to the printer. So thank you very much, and hope you enjoy all the new features in with beautiful designs. Thank you.